Hello Year 5 and welcome to your next lesson about fractions. So for Rahan, who was curious as to whether we were going to do equivalent fractions, here is your lesson today on equivalent fractions. Now today's lesson is going to be slightly longer, okay, because we're combining two of our lessons into one. This lesson should be fairly short, but it'll be the next video and the next lesson that might take you a little bit more time. So if you don't finish all of the worksheet from this sheet, that's fine. What I might suggest is you do only the first part of the activity and then we'll move straight on to the next part of the lesson. So let's warm your brains up first. So pause the video and have a go at these 4 questions. Okay, so work out 24 multiplied by 13. So this is timesing our 2 digits by 2 digits, and we spent the last 2 weeks doing it. The answer is 312. A bus carries 46 passengers. There are 3 full buses. How many passengers in total? So we're going to need to divide those 46 passengers by 3 buses, and that should give us 138. My apologies. You're going to multiply it because we have more than those buses. What is 150 divided by 3? So we do our short method. Equally, you could do, well, how many 3s are in 15? Well, we know there's 5, but we're multiplying it by 10 to multiply the answer by 10. Based on that, the next answer we should know, because we've now multiplied it by 100 here, it's now got to multiply it by 100 here rather than the 10. So that gives us 500. So for this question here, what I'd like you to do is you need to work out using our greater than, smaller than, or equal to, so our inequalities. You need to try and work out which fraction is bigger, smaller, or the same. Okay, so pause the video and have a go. Okay, so a quarter, okay, is smaller than a half. Okay, we split something into 4 and we split something into 2. We have more of it if it's split into 2. Now 1/2 is and 7/14. Well, if we notice, if we do 17 multiplied by 2, that gives us 17. So that must mean that 7 is half. Therefore, these ones are the same. Now, these two have different denominators, so we need to work out, well, how do we work out which one's smaller or bigger? So if we look at this one, we know that 13 is half of 26. But if we look at this one, we know that 15, okay, is less than half than 31. So without having to work out any of our numbers, we automatically know that that one's going to be bigger, okay? So half there is bigger than this fraction here. 3/5 and 2/5, well, we know that our denominators are the same, so we're looking at our numerators. 3 is bigger, so that makes 3/5 the biggest number. So well done if you got those correct. So when looking at equivalent fractions, when we say that something is equivalent, it means that it's the same, it's equal to, the amount is exactly the same. Okay, so it's equal. Equivalent, equal. So let's take this fraction. Okay, so we know this is a quarter. Can you remember what the bottom number's called? Good, well done. Okay, it's the denominator. So how many equal parts we have altogether? What's the top number called? Okay, numerator. So this tells us how many parts that we're going to be using. So let's have a look at this square. We did this in the last lesson. What's wrong with these squares? Okay, so we said they've got to be equal parts. They're not equal. Yes, we have 4, but they're not the same. So let's fix it. If I had 1/4, I can shade in one of the squares. Equally, like last lesson, we know we can fill it in wherever we want. It makes no difference as long as one is shaded. Well, then let's have a look at this fraction of 2/8. So we know that our denominator is 8, so we need 8 equal parts. Now, our numerator tells us how many that we're looking at, so we need to shade in 2 of them. So let's shade in 2 of them. What do you notice about those two fractions? Okay, so if we put them together, you can see that 1/2, okay, or 1/4 rather, is equivalent to 8. They are the same, because if we do 2, 4, 6, 8, we know that 2 is going to be 1/4 of 8, whereas 1/4 here is exactly the same. So they are equivalent. They are the same. So let's look at this one. Is 6/9 equivalent to 2/3? Well, let's have a look. So using our denominators, let's have a look at putting these into our rectangles. So here I have 9 equal parts and I've shaded 6 of them, okay, because my numerator tells me how many we're looking at. Here I'm going to do the same thing with 3. So I've got 3 equal parts and I've shaded in 2 of them. If I put these together, you can see that they are equal. Because let's think about it. If I'm going to divide 3 by itself 3 times, I'm dividing it by 3, so that's 2. So 1, 2, and 3. So I know that 1 is each one of those thirds. If I look at 9, how many 3s are in 9? Well, 3, 6, 9. So I know that 1/9 is going to be the same as 1/3. 6/9 is going to be the same as 3/3. And if I had 9 9s and 3 3s, they're the same. Okay? So you need to think about how we get from the top to the bottom, which we'll look at in a later lesson. So 6/9 is equivalent, so it's the same as 2/3. as is 2/3 being equivalent or the same as 6/9. So this is where your times table knowledge comes in year 5. So pause the video and have a think. Which one's the odd one out here? Okay, well, let's set out our rectangles, our equal parts of our shapes. If we move these all together now to match the right fractions, we can see that 6/9 and 4/6 is the same. Okay, so if I did my sixes, this is in groups of 3, this is in groups of 2. Okay, so I've got 1, 2, 3, 4, 5, 6. Okay, and we've got 1, 2, 3, 4. We can see that they are equivalent. Okay, we've effectively shaded in 2/3 of both of those numbers. 4/9 on the other hand, though, is not equal. Therefore, that 4/9 is the odd one out. Okay. Now, I've sent a copy of this home for you to be able to look at. Okay, I'm only going to show you one example because it does get quite complicated. So, for example, let's have a look at 1/6. Okay, what fractions could be equivalent to the same as 1/6? Now we can see if we look through that line doesn't cut directly down any of the black lines for 7ths, 8ths, 9ths, 10ths or 11ths, but it does cut down that line there for 12ths. Now if I know that's 1/12, that must mean that missing one there is 2/12. So that tells me that 2/12 here is exactly the same, so equivalent to 1/6. Okay, they take up the same amount of space. Let's look at another example. Okay, let's look at 3/4. So we've got 1, 2, 3/4. So we're looking at this line here. Okay, so let's draw that line all the way down, and we can see it's not equivalent to any 5ths, 6ths or 7ths, but it is equivalent to the 8ths here. So how many 8ths? We've got 1, 2, 3, 4, 5, 6. It's equivalent to 6/8. Okay, and if we scroll down, we know it's equivalent to 19. If we count these 9ths all the way across, that gives us 9/12 there. So that tells me that 3/4 is equivalent, so the same as 6/8 and 9/12. Okay, so using those lines on that grid will show you which fractions are the same as fractions that almost seem like they get bigger as we work down our charts. So what I would like you to do is I would now like you to have a go at doing question 1 to 4 on your worksheet, and then we're going to come and look at a quick problem solving question before we move on to the next part of our lesson. So pause the video and have a go. So always, sometimes, never. So the greater the numerator, so the number on top, the greater the fraction. Well, let's explore that. 1/7 and 4/7. Okay. Let's split this into our grid. So we've got the same denominator, so we've got 7 equal parts. Okay, here's one part that's shaded. Okay, here's the same fraction but with 4 parts shaded. What do you notice? Okay, so in this example here, the greater the numerator, then yes, the greater the fraction. Okay, however, that's because our denominators here are the same. So rather than having one piece of pizza that has 7 pieces, I'm going to eat 4 pieces of that whole pizza that's cut into 7. Therefore, I've eaten more pizza. So the greater that numerator, then yes, the greater that fraction, as long as the denominators are the same. So let's explore that then. So here I've got a third. I'm going to shade in 1, okay, because my numerator tells me how many. Here I've got 2/10. Now my numerator here is bigger, okay, but my denominators weren't the same. So here I've got 10 equal parts. I've shaded in 2. Now it says that the greater the numerator, the greater the fraction. Does that look true in this statement? No, it doesn't. Okay, so here you can see it's not equal. So that tells me that it sometimes could be the case because it was the first time round, but it wasn't the second time round. So it's only valid when the denominators, so our bottom 2 numbers, are the same. If the bottom denominators are different, we have to work out different equivalent fractions to work out whether it's greater or the same. Okay, so for that one, it's going to be sometimes. So based on that, please have a go at question 5 and then come back and watch the second part of our video where we move on to the next part of our lesson.